Today's topic is about history and monitoring for construction workers. This research focus on using multimodal sensing to understand how physiological strain develops under heat stress, heat exposure, uh, with the ultimate goal of building the data-driven threshold for history management in construction environments. For today's gender, I will first introduce the background and explain why heat stress remains a critical issue in constructions. Uh, and then I will describe our research methodology, including the sensing framework and monitoring strategies. And finally, I will walk through our experiment, including the laboratory phase and real job site deployment. First we can dive into the background. Heat is the leading cause of the death among all weather-related hazards in United States. According to OSHA, thousands of the worker experience serious heat-related illnesses every year. Um, Data from the um, BLS shows that between 2011 and 2020, more than 33,000 uh, 3,000 work related his injury result in days away from work. And construction workers are particularly vulnerable. They work outdoors for extended periods, perform physically demanding tasks. Despite these risks, most most current safety guidelines rely properly on environmental measures such as like the Higgs index. Then the environmental cuts off does not capture individual physiological variability. Uh, for example, like two worker exposed to hit the same temperature may experience very different level of the internal strain. So this gap motivates our research. So in the research methods, um, our idea is the monitoring should not like only observe the condition, but generate the data necessary to build up occupational specific physiological thresholds. We decide a multi-model sensing framework that integrates two major components. The first component is the wearable sensing device to monitor the physiological factors. The second component is the computer vision. By combining external exposure information with the uh, internal physiological response, we can observe how heat string develops dynamically over time. And we can see we for the research mainly through the through upstream to downstream, we use slate safety band V2, H job for the second for the sodium concentration monitor with the purpose of the collecting this data is not simply monitors for alerts, but statistical identify when physiological response begin to deviate from normal adaptation patterns. So and not only like monitoring. So when we go to the construction site, we also provide the heat interventions for protecting construction workers um, to let him go through smoothly for our monitoring projects. So in the heat we have the three interventions. The first one is internal interventions, including hydration, electrolytes, uh, and the cooling methods. And for external interventions, we include involve like shade area, uh, mist spreading, flame cooling. For the administrative interventions, of course, for heat stress monitoring, we deliver the physiological monitoring, uh, and we include cold ward rest cycles, uh, acclimatizations, and cell spacing as well. So our research contributes to this framework, like integrates like the infrared camera, the thermal camera as well. You can see from the lab-based experience, we capture uh, the surface temperature from using the camera like FLI 870. So and we use these images and we label. So since they wear the slave safety sensing device, we have the core temperatures. We label the core temperature using the thermal imagings. So and we applied with this. We apply with the computer vision method like YOLO. I think right now it's YOLO V11 is the SOTA model, and we can detect the core temperatures for one of the indicators we developed for the threshold, so we can get rid of the wearable sensing device in the later further research. And we also did the in-class monitoring from this whole uh, uh, process. So we participate we recruit the student participants and to do the experiment in class. And after we collect the data, we do some analysis to build out the threshold. And in last semester, we did the HM monitoring with the one of the company called Wellman. This job site they provide was in Galando, and um, we looked through the schedule coordinated with the superintendent. Uh, we find out the most representative job type we can let them to represent the most job type exposed to the heats, and we let them to participate with our heat monitoring. Let them to wear our sensor device and monitor using their infrared camera as well, and let them to fill out the survey every monitoring day, every experimental days, and this is how we process in the job site. And this the job site pictures. This is the whole 10 days monitoring project. So we go to the job site and capture every day's daily work scenario environment. This is how it looks like. And after all, we collect the data we want, and uh, we do the analysis finally, and we have a good report eventually. So yeah, that's everything for the HM monitoring projects. Thank you guys.